Shake Table Lab by Henry Pillara and Ryan Brennan. The plan for our building was for it to be very reinforced with lots and lots of tape, but also for it to be shaped like an arrowhead. It was supposed to concentrate strength in the main parts, but leave no strength in unimportant parts. First, we started by laying down foundations and using tape to strengthen vertical and horizontal beams. We drilled straws into the base to attach the building onto it. We used a system of connecting straws and tape to lock them onto each other, forming a skeleton of the building. We also used cross beams and X's to make it much stronger against earthquakes. A lot of tape was used, maybe too much, to make the building very strong in order to make up for the weakness gained by the vast height of it. We also put huge amounts of tape on the connections with cross beams and vertical straws. The roof of the building was designed like an arrowhead, and it was a bit spiky like Orthing Tower. It is probably one of the most distinctive features of the building. The completed tower is huge, at 90 centimeters high. We used a huge amount of tape and paper to draw Illuminati designs in order to customize it to fit our own needs. Static testing was the process of putting weight in the form of sandbags on the tower. It helped to test the strength of the building prior to the earthquake. We reinforced the beams by slipping the straws inside each other further and sealing them with tons of tape. A method was also used to connect the roof covering on the inside with tape so that it did not show. The strongest parts of the building are the uprights and the crossbeams because we put huge amounts of tape in those parts. They are strong because they are especially made to withstand an earthquake using tape around the points where the straws connect. The weakest part is the roof. It is weak because it has less tape and is one of the areas least affected by an earthquake. We built it for the aesthetic appeal rather than its strength. Tape is mainly focused near the bottom of the building because that, we predict, will be more closely affected by the earthquake. We used so much tape that on some places the straws inside could not be felt. Flooring was a very important part of the process. Colored paper was used to make the floors, and vertically facing straws were used to hold them up. The opening test of our building on the shake table was successful. The building stood up to the earthquake.
Minor earthquake.
After several earthquakes, the building fell into ruin, partly because of a messed up crossbeam.
Oh no. What? No, that was rigged. No, I made it.
The XYZ graph shows the movement of the tower during the earthquake. The X shows side-to-side motion, the Y shows forward and back motion, and the Z shows up and down motion.
Our tower supported 10 sandbags before failing at 12. One of the reasons for it was because it was very, very tall. If I were to change something about it, it would be to make this tower shorter so one of these cross beams wouldn't pop out. This is one that fell out during testing and what ultimately led to our tower's destruction. I learned that attention to detail is very, very important in building buildings because it can mean the difference between failures and surviving an earthquake. I really enjoyed making the roof, even though it's probably what caused our tower its destruction, because it was fun and it added a unique aspect to your building so you could tell it apart from everyone else's.
Our tower had 10 sandbags and failed at 12. I think that the building's height and a messed up crossbeam were the main causes of its destruction. It was too tall, and if we had checked all of the crossbeams, it may have survived longer. Something I would have changed about the tower was checking all of the parts and maybe reducing its height so that it was less top heavy and less likely to fall over. that you really have to look at a building's design to find points of weakness in the structure. I also learned the importance and the challenge of making earthquake-safe buildings for urban residents in large cities. Something I enjoyed about the project was the creative aspect, where we got to customize the roof of the building and use different colors to decorate it. Overall, I really enjoyed this project.